Hello, and welcome. In this video, we will show you how to perform linear regression using the Tensorflow library. Linear regression is a technique for describing the relationship between two or more variables. Simple linear regression involves only two. The dependent variable is the value that we want to analyze or predict. The independent variable is explanatory and is used to predict the changes in the dependent variable. When there are multiple independent variables in the model, the process is called multiple linear regression. When there are multiple dependent variables, the process is called multivariate linear regression. Let's look at a well-known simple linear relation. In this equation, y is the dependent variable and x is the independent variable. So essentially y is a function of x. A represents the slope or the gradient of the linear function, and b represents the intercept. Both a and b are model parameters that can be adjusted. If you plot the model, you'll see that the result is simply a line. Adjusting the slope parameter will change the angle that the line forms with the independent variable's axis. The intercept parameter changes the location where the line crosses the dependent variable's axis. Before we move on, we'll need to import some libraries that we use throughout the video. Now let's see an example of a linear equation. We can form a more meaningful view of linear relations by looking at the real-world phenomena they describe. One example is the relationship between speed and distance traveled. Linear relations can also describe the properties of different materials. When we want to perform simple linear regression on a collection of data, we need to adjust the slope and intercept parameters so that the resulting line fits the data points as accurately as possible. Now let's perform linear regression using TensorFlow. Before we start, we'll generate a set of random data points using a known linear equation, and then we'll attempt to recreate the parameters with regression analysis. This is the equation we'll use to generate random data points. There's nothing particularly special about this equation. We just need a data set to work with for this example. Feel free to change the parameters if you'd like. Here is a sample of the data we just created. To start the regression, we need to initialize our variables a and b with random values. These initial values will almost certainly result in a poor fit, but we'll adjust the parameters during training. Once we have these values, we can then define our linear function. For linear regression, we need to specify a loss value that will be minimized during training. We'll define the loss as the squared error, where error is the difference between the model's prediction and the actual value from the dataset. To compute the loss, we can use the function tf.reduce_mean parentheses. This function calculates the mean of a multidimensional tensor, and the result can have a different number of dimensions than the input. We then need to define the optimizer method. For our purposes, we'll use a simple gradient descent with a learning rate of 0.5. The minimize method will calculate the gradients and apply them to our variables. And don't forget to initialize the variables before executing a graph. And with that, we are now ready to start the optimization and run the graph. At this point, you should understand how to perform simple linear regression using TensorFlow. Thank you for watching this video. To practice and learn more, go to the lab and run the code for yourself.